Hi everyone, welcome to our next lesson. So the first thing I would like you to do please is pause the video and have a go at these practice questions that use Ohm's law. So pause the video and I'll go through the answers in one moment. Okay, so question number 1. What is the resistance when there is a potential difference of 2 volts and a current of 5 amps? Oh, that's way too thick, hang on. There we go. Okay, lovely. So R equals V divided by I. 2 divided by 5 is 0.4 and its resistance, so it's ohms. The dodgy ohm looking symbol, there we go. Number 2, what is the voltage? When there is a 2 ohm resistance and a 2 amp current, V is IR. 2 times 2 is 4 and its voltage, so it's volts. What is the current when there is a potential difference of 10 volts and a resistance of 2.5 ohms? I is V over R. Is 10 divided by 2.5 equals 4 and it's current, so it's amps. Number 4, what is the resistance when there is a potential difference? So R is V over I, 15 divided by 3 is 5 ohms. Number 5, voltage, V equals IR, so that's 0.4 times 2.5 is 1 volt. And number 6, what is the current? So I is V over R, is 16 divided by 8, it's 2 amps. Lovely, lovely. So, last lesson we looked at current voltage graphs for a resistor and a bulb. Now just a quick reminder of what they should look like. So you had a resistor, and they were cross graphs if you remember, and you had potential difference on the x-axis, current on the y, and with a resistor, you got that real straight line, and it followed Ohm's law. So as you increase the voltage, you also increase the current. Lovely. With a bulb, it looked slightly different, if you remember. You had this, that's IV again. Oh God, that's so wonky. Let's try that again, shall we? Bit slower. There you go, that looks much better. You had again that IV, and again if you increase your voltage, you increase current. But whereas with resistor, they were proportional to each other. I'm sure you've seen that symbol in maths before. In a bulb, they are not, and that's because as you increase the voltage, fine, yes, you do increase the current, but you also increase the temperature, if you remember. And the hotter the bulb gets, the more resistance there is. So it's all about temperature with bulbs. So we're going to go on and we're going to do a little bit more on current voltage graphs and generally graphs. So if you can either carry on after last time, I don't mind. If all your notes were on graph paper, etc. last time, then perhaps write this as a title. But either way, we're basically carrying on from under last time. So the first thing we are looking at, sorry I got distracted by an email there, diode. A diode is a component which only allows current to flow in one direction, and its circuit symbol looks like that on the right hand side. So can you see it's made up of an arrow and a line? Now if current wants to flow in this direction, it can. If it follows the direction of the arrow, current can go round. However, if current tries to go the other direction, it cannot flow. The reason it can't flow is there's a massive resistance in one direction. So if we did a current voltage graph, we did exactly what we were pretending to do last time. We put it in a circuit, we made current go around it, we increase the voltage, and we looked how current goes. Lovely, one direction, we get a really nice graph. If we flip that diode over and try to get current to flow the other direction through it, we don't get any current flowing. And that's what's being shown on that graph there. So if you can please copy this graph. On the right-hand side, in the kind of positive direction, fabulous. As voltage increases, current increases. But on the left-hand side, you see that there is zero current because it can only flow in one direction and because a diode has a very high resistance in the other direction. Okay, so the next thing we're going to do, I'm afraid, is imagining we're doing a practical. So the practical looks at something called a thermistor. And a thermistor, and don't worry, we will write this down so you don't need to make notes right now. So a thermistor is a resistor, which you can kind of tell from the name, which depends on temperature, hence the thermistor. So what I would get you to do is attach it to something called a multimeter, which looks like this, and it's got a little dial on it, and it can measure current, voltage or resistance, hence multimeter. You can measure whatever you like. And we're going to be we would measure resistance with it. So what we do is we'd heat this thermistor up or cool it down to different temperatures, and we'd measure its resistance. So that we could tell how, I know it depends on temperature, but is it that there's more resistance when it's hot, less resistance when it's hot, etc. So what you would do is do all of that and you get some results. So what we're going to pretend, sorry, I know it's annoying, is that we've done this practical, lovely, and you've got some results. So let's go for a resistance of 2000 ohms at 30 degrees. Then let's go for 1000 and then 500, 250, 125, 60. There you go, right. So what I'd like to do for me, please, is screenshot the video right now, and you're going to use these results and a piece of graph paper, and you're going to plot it. So I'm going to stop the video, and I'd like you to plot these results on the graph paper that I popped on Google Classroom, and then there'll be a second video where we start doing notes, etc. All right, thanks everyone, and see you in the second video. Oh, sorry. Oh, goodness me, don't go anywhere. Should have said what you're going to do. Such an idiot, sorry. Temperature on the bottom, on the x-axis, and resistance up the side. Okay. And obviously you need to go up to 2000 on that. Please make sure your axis is evenly spaced, so you could always go up in hundreds, etc. And temperature, you'll obviously need to go up to 80. All right, really, thank you very much everyone, and I'll see you in the next video.